Hello, everyone. It's Alan Schimmel. It's DevOps.com, and you're listening to attending another DevOps.com webinar. We've got a really good webinar and a really hot topic today when we've got a real life practitioner expert who's going to talk to us a little bit about her own experiences. Today's webinar is entitled Deploying Compliant Kubernetes, Real-World Edge Cases, and it's sponsored by our good friends at ThreatStack. Before we get started, let me say that there are few topics as hot in the tech world today as Kubernetes. I was at a KubeCon last month. It was sold out. You couldn't get a ticket. And the buzz there, to me, was reminiscent of AWS reInvent 5 years ago. So it's reflected in the amount of people we've had register for this event. It maybe double of what we get in the usual DevOps.com event. That being said, though, I wanted to just take a moment and say that we have set aside time for questions today. And the way we do questions on our DevOps.com webinars using the GoToWebinar system is that if you look in your control panel, which for most of you is in your upper right-hand corner of your screen, you'll see the different sections. One of them is marked questions. And if you hit the arrow or caret so that it becomes downward facing and expands, you can see that you can type your question in there. And that's a great thing, right? Don't wait till the end of the webinar to ask your question. There's usually a rush, and we have to start picking and moderating. If you can get your question in early, it gives our team a chance to see the question, prioritize it, get it ready. If it's something that could be answered offline privately with you, we can do that as well. So please type your questions in as soon as they pop in your brain. You don't have to, or your head. You don't have to worry about forgetting them later on, and so that all the questions aren't about just the last slide, right? Type your questions in real time. We'll take care of it. On DevOps.com webinars, though, if you're having a technical issue, perhaps the audio's not working well, or slides aren't advancing, or something like that, but you can still get into the control panel. The chat section down below is available to you. We don't use chat to ask questions here. We use chat if you're having any technical issues. We do have monitors monitoring the chat window standing by, and they're there to help you if you have any, as I said, technical kind of questions or issues. So please avail yourself of that if you need to. Hopefully you don't, and you can get the full benefit of today's webinar. I should also mention that today's webinar is being recorded. The recording and the slides of today's webinar will be available on DevOps.com, usually within just a few hours of today's webinar. We're already starting to get questions in there in our question section. That's great. I appreciate it. We'll get our team on that. As I mentioned, today's webinar is Deploying Compliant Kubernetes Real-World Cases. We're very lucky to be joined by Paugh, who's the DevOps Team Lead at Lola. And for those of you who aren't familiar with Lola, it is in the travel and tracking, employee travel and so forth industry. Katie can tell you more, but she's not quote unquote a vendor. She's out here doing the same kind of jobs that you are and dealing with the same challenges and issues and problems that we all of us in the DevOps world, not only the DevOps, in the technology space, face day to day as we try to do more faster, better, and more securely. So with that being said, I'm just going to, again, thank ThreatStack for sponsoring today and their help with this. And let's introduce Katie. Katie, you there?
Yeah, I'm here. Hi, everybody.
Great. Katie, I'm going to hand it over to you. And I should mention that we also, Tim, I apologize. VP of Application Security Products, Tim Buntel from ThreatStack is on board as well. I'm sorry, Tim, but you're not the star today. It's kind of Katie, but you're always a star, man. We work together.
No problem, Alan. We're 100% with you. Katie and her team have really been leading this journey and this content. So I'm just here. I've been supporting them and working with some of our customers on these same issues. So I'll chime in from time to time, but largely, Katie, we're going to have you take the lead. So take it away, introduce yourself, and get going.
There we go.
Awesome. Yeah, so I'm the DevOps Team Lead here at Lola, and just a little bit about Lola. If I can get this. Oh, there we go. Lola.com makes managing corporate travel easy, fast, and agile. We provide your company with the visibility and control that you need while giving your travelers the amazing experience they want. So from a technical standpoint, we have like a desktop application and a mobile application. Users put their credit card info into the app where their profile information is. They can book flights and hotels. We have a 24/7 travel agent team that's supporting the users. And being in operations, we have to support those travel agents 24/7. So we want our infrastructure to be resilient and stable and fast healing, like we all do in DevOps. So our cloud infrastructure, when you're in compliance, the first thing you want to do is you want to make sure you're separating out your PCI or any of your compliance infrastructure from the rest of your infrastructure. You want to limit the scope. So the way we did that is we have an entire AWS account dedicated to PCI infrastructure. And there we have a Kubernetes cluster where we have network segregation separating the staging environment we have in the infrastructure and the prod environment we have. In our general infrastructure, we're running things like that's where bookings actually happen. We do flight searches. We have analytics. Some internal tooling is running over there. A lot of our monitoring and operations is in general infrastructure. PCI is just handling credit cards, sending credit cards to our vendors to actually do the bookings on behalf of our customers. We are a small team here. Our DevOps team is only 3 people. We manage everything from general IT to AWS infrastructure, our CI/CD pipelines, security, compliance. We do the audits for PCI. We manage the Kubernetes clusters. We have to manage our logging and monitoring. We manage a lot of things. With a team our size, it just isn't optimal to build everything from scratch. We'd spend all year just working on monitoring. We use a lot of third-party products and open source products just to keep Lola.com running and operational. So we have about 13 to 16 core containers running per environment, and then about 20 just supporting analytics, monitoring, and logging. We use COPS which is KOPS for those who haven't used it before, to manage the state of our cluster. So that's what our infrastructure looks like, what size nodes we're running in AWS. And then we use Helm, which I'll go into more detail in a minute, to just manage the state of each environment. So we know exactly what each of our dev, staging, testing, QA, non-prod, we know exactly what every environment looks like, and we have fast deployments to get back to a stable state. So why do we need compliance? We're not actually processing the credit cards. Well, we do store credit cards. We don't want users to have to input their credit card every time they're making a booking. So they just put their credit card in one time. And then every time they do a booking for flight or a hotel, we grab that credit card from our database, send it to our third-party vendors that actually do the bookings and do all the processing of the credit card data. We also have in-house travel agents, which I mentioned earlier, and they can book on behalf of our customers. So if a customer's having trouble with the interface and they just can't find the flight that they want, our travel agent can reveal the credit card and then use that to book on behalf of the customer. There's a lot of regulation around that, who can see credit cards, why, when, how often. So that's all things we have to cover. We also don't, like I mentioned earlier, we don't process credit cards, but we are level 1 PCI DSS compliant. So what that means, PCI in general, the PCI Security Standards Council was created by all the big credit card vendors. You have Amex, Discover, JCB, MasterCard, and Visa. They created a bunch of standards around handling credit cards, processing, storing. So unlike SOX, HIPAA, or GDPR, they're not legal requirements, though some states are making it legal. So like Nevada and Minnesota have passed laws saying that you have to be PCI compliant if you're doing so many transactions per year. So for PCI, there's about 6 general controls and 12 broad requirements. You have to do quarterly reviews and scans. There's a yearly assessment that you have to bring in, either a third-party qualified assessor, or you have to have your own internal one. Yearly assessment not only ensures you're following a documented process, but just making sure the spirit of the standard is adhered to. When we go into the requirements in a minute, you'll kind of see how vague they are. You have to assess what applies for you and your company and figure out, well, requirement 1, only certain subsections apply to me. Other things we're not really doing, so we don't have to follow. So it really does depend. And the PCI DSS is just for storing credit cards. There are different PCI standards for if you're actually processing. But we decided to be level 1 maximum PCI DSS compliant, just so if we decide to switch to something further down the road, it's going to be very easy for us.
Hey, Katie, Tim, quick question here. So, I work with lots of different organizations that are in the same sort of stage of, they don't actually have to be fully compliant, but maybe they're looking at the regulations in those compliances just to help them get a better roadmap for how to approach security in their industry, or to use it as a signal to their customers and partners that they take security seriously. Has that been beneficial for you guys as well? Has your work on the PCI side helped influence your security stance generally, even in your non-PCI environments? And do you get some benefit in the market for addressing this stuff?
Oh, definitely. People get really excited when we say that we're PCI compliant, and it's really put our foot in the door for other kinds of compliance. We want to do SOX or something else down the road. All those controls are already in place. We just may have to tweak some of our processes, but it's been a huge help. And we definitely do apply a lot of what I'm going to talk about here on our non-prod cluster as well. Just having those general security standards in place. This is just best practice in general. So I highly recommend putting it as many controls everywhere. But for scope of the audit, separate them just to save yourself some headache when you have an auditor in your office and you're explaining all the controls about why service X, Y, and Z doesn't talk to PCI service A, B, and C. But no, definitely these security practices are something that should be applied everywhere.
Great. So I think we're all eager to get into some of the requirements. So especially because I know in the Kubernetes world, things are evolving really quickly, and the way that we're architecting our applications, often many of us practitioners don't even struggle to keep up with the pace of change. Certainly the auditors must be in the same. So why don't you just kind of walk us through some of these requirements, and we'll pause at each to have a little bit of a conversation, and then take questions at the end.
Yeah, it sounds great. And just want to reiterate going into this that all the requirements of PCI are really vague and encompass a wide variety of technology. You really do need to sit down with your engineering teams or your compliance team to decide what applies for your specific company and what you can assume is just not applicable for your setup. In our case with Kubernetes, things that are really relevant are going to be like development and deployment practices, network security. Less relevant for us will be like antivirus, physical access, and those kinds of things. So diving in, requirement 1, right off the bat, is installing and maintaining a firewall configuration to protect cardholder data. That's pretty much a huge can of worms. So the kind of things you need to start questioning and asking yourself are, well, what physical and logical security are we putting around our cluster? How do we stop any generic person from trying to access or DDoS our systems? And just start thinking about those kinds of external controls to protect your environment. So what we do is we rely a lot on the AWS shared security model. Our entire infrastructure is in AWS. We have like 1 or 2 tiny build servers just for testing in our office, but none of those are PCI. So just looking at this diagram we have here, we have a separate AWS VPC just for PCI. All traffic comes in via internet gateway, and we'd follow the public-private subnet concept. So here, the only place internet traffic can enter is via our DMZ, which is our public subnet. And the only things there are our WAF, some load balancers for specific traffic that we have. We have a NAT that's doing like the network address translation for our application servers. And we have a Bastion host in case if we ever have to actually get onto any of these servers, which is very rare. With Kubernetes, luckily, you don't have to do a lot of node-specific things. But those are the only things that are publicly facing. So if we wanted to hit any of our services in our CDE, our customer data environment, we would have to, we would end up going, all of the traffic would go through the WAF and then through the elastic load balancer that AWS has, and then that would be trafficked into our cluster. And inside of that restricted subnet, we also have like our Redis cache and our database. None of that is publicly facing. You have to be within the network to even get to it. So the bastion is how we SSH into our cluster. We use kops to create, destroy, upgrade, maintain our Kubernetes clusters from the command line. If you're using kops to stand up your cluster, we highly recommend that you look at the settings SSH access and the settings Kubernetes API access. Those let you set which IP addresses have access to your Kubernetes cluster. We've limited that strictly from the only way you can SSH to our cluster is if you're on the Bastion host, and the only way you can get API access to our cluster is if you're in our office or on our VPN and you have the proper credentials. So we highly recommend when standing up your cluster, you look at those two settings.
So, Katie, as you know, speaking of this kind of setting things up, and I know that some of this might come through blueprints, you know, that AWS might provide, versus sort of how much of this was trial and error on your part. You know, did you feel like there was a good roadmap out of box to set up this particular environment that you guys settled on, versus how much of it did you have to do on your own through customization, trial and error to satisfy the requirements here?
Yeah, so AWS does a good job giving you like an out-of-the-box setup, but they do leave it wide open. So from a security standpoint, you really need to go over every setting with like a fine-tooth comb. The biggest thing we always joke about in DevOps and all the AWS meetups is that AWS gives you just enough rope to hang yourself with. You need to actually, they give you everything that you need to set up and secure your environment, but you need to know how to use it. So I would definitely recommend if you're new to AWS to go to meetups and talk to other people, read blog posts, see how other people, what settings they're using, because there's security groups, there's web access firewall rules you need to put in, there's VPC and subnet routing, there's ACLs that you can use, and all of that you have to know how to configure right out of the box. It's going to be wide open, anyone can hit anything. So while nice to come out of the box and you're able to set up an application, you're not going to come out of the box being compliant. So then we have requirement 4, which is talking about, you know, encrypting transmission of cardholder data across open public networks. The key here being public networks. Once you're inside of your VPC or your network, they don't really care what you're doing between services. We use TLS encryption via ingress controllers. If you haven't used an ingress controller before, it's like a Kubernetes load balancer. It manages, you can use it for DNS management, you can use it to manage your encryption, you can use the host certs. It just maps to, in our case, an AWS ALB, application load balancer. So everything through the load balancer goes to the ingress controller, and the load balancer is what's managing like what IPs can hit the cluster, on what ports and with what security, and the ingress controller is managing, well, which container is this going to? What traffic is on here? Do I need to do any manipulation to it? Does it go to all the containers, just one of the containers? And it does that kind of management for you. So on the ALB, when you set it up, there are 2 things you want to look at. You want to look at the security group, which I mentioned a second ago. You want to be able to manage who and how they're accessing your cluster. So do you want them to be able to hit you over port 80, or do you want to restrict it to port 443, or do you want them to restrict to, like, if you're running Postgres, like the Postgres ports? Do you want anyone to be able to hit that port, or do you want to restrict it to office IPs or IP ranges that you have reserved for your application? And you need to be able to define all of that. There's also an overlooked setting that a lot of people don't know about, which is the ELB security policy. That's where you define which encryption algorithms are allowed to be used. So by default, the encryption algorithm, there are a few encryption algorithms on the default security policy that are not compliant. They're very old, but a lot of old browsers still use them. And you just need to you need to clean that up. You can just, it's all checkboxes. You can just uncheck the ones that aren't secure, and it's pretty straightforward for setting up. We also use Weave as our networking layer, so that could be like your Flannel or your Calico. We just chose Weave because it was out of the box, very easy to set up. We didn't have a lot of configuration we had to do for it. It just ran, and that was huge for us trying to migrate to Kubernetes. And there's just a setting when you're setting up Weave that enables encryption between services. And we just wanted that extra layer, so if someone got onto our network and was doing like packet sniffing, they wouldn't be able to see all the traffic. we believe a lot in encryption at rest and encryption in transit. So anywhere we can set a setting that's just a flip of a switch to encrypt something, 100% we're doing that. But it's not a PCI requirement to encrypt between services, it's just highly recommended and good practice. And PCI is constantly updating their policies, so you might as well add it now when it's easier than you're already doing this kind of audit than it would be if when you're down the road and you've scaled X-fold and there's suddenly a requirement and you have to add that transmission.
So, Katie, we are supporting lots of folks and getting involved with a lot of projects that are looking at using service meshes. So, for example, Istio. I know there's the notion of kind of inter-service mutual TLS. Is that something that you guys looked at, or is that something? Are you using microservices, and does the service-to-service communication come up at all?
Oh yeah, service-to-service communication was the main reason we went to Kubernetes. Before, we have a lot of services that talk to each other, and they're all talking to each other for different reasons. And we can see all of that in Kubernetes, which is huge. With a service mesh, we've looked at using that, and we're actually talking about migrating to that in the next year or so, either Istio or an Envoy or one of those. So it does what Weave does. In fact, it encrypts the traffic between your services, but it also gives you some fine-grained control over traffic behavior. You can do like some rich routing rules and retries and failovers. You can even do like fault injection, which is amazing. There's a lot of, it's a lot of setup to do. I'll say that Istio kind of has a learning curve with it, but so does Kubernetes. It seems to have a lot of pros, and that's why we're still evaluating it, and something that we're definitely thinking about moving to soon.
Great. Well, it's something that I've been looking at quite a bit lately, so maybe we can come back together at some point in the future and do another webinar on that topic. It's a great, fascinating topic. So.
Oh, definitely. Talk to me in like 3 months when we've experimented with it a little more.
Great.
So then we're on to requirement 6. If you notice, we're skipping some requirements. They're just not applicable to Kubernetes. They may be about training your employees or other things. In this case, requirement 6 is developing and maintaining secure systems and applications. So this one covers a lot of ground. Section 6 has a lot of subsections. Read through them, see like what's applicable for you. Some of the things that you need to ask are like, how can we design our infrastructure in a secure but scalable way? The constant thing in DevOps is like security versus availability and scalability. Security does kind of like lock some doors, so you just kind of have to balance what you want. Luckily with PCI, they understand that. They believe that they understand that if you have like a business use case, then you can't do everything. But you just kind of have to have that written down saying we accept this risk. You also need to talk about if you need to be able to create new resources quickly, how do we keep database credentials and secret access keys during deployments? Those are all things you have to think about during this requirement. In our case, we use Helm. If you haven't used it, Helm just templatizes Kubernetes charts, which means that we can use one chart for dev, staging, and prod and just trade out variables, which is amazing. It means that we know that dev looks exactly like staging and prod. It just may have different subnets, it may have different environment variables, but from an operations perspective, they look exactly the same. Helm also lets us version control and tag infrastructure because we can check it all into Git. So Helm also has this concept of like packages. So you can make a package of your entire environment and you can sign it. So we know this was signed version 2.3.6 of our environment. This was the change that was made. We have PRs for all infrastructure changes. So we can point out being like, well, this rule was added to this service this day. It was approved by this VP of engineering for these reasons. It was an emergency patch because of X, Y, and Z. All that's documented in Git. Documentation is a huge part of PCI. You have to show you have processes for everything. It's honestly a huge part of most compliance standards. I know it is for SOX and HIPAA. HIPAA is primarily documentation and processes. So being able to just point to a Git log and a Git PR and be like, this is associated with these changes is huge. The Git log, we have a Git log for every infrastructure change, and all of our Git commits are signed by our engineers. We won't accept a PR or a Git push from anyone that doesn't have a signed Git PR or a Git signature. With partnering with Helm, there's a plugin called Helm Secrets. We keep all of our environment variables and access keys in Git encrypted. So they're in Git, but even if you got into our repo, you wouldn't have access to them. Helm Secrets kind of partners with AWS KMS keys, which KMS is their key management service. So a user has to have access to the repo and access to this KMS key in order to decrypt the file. If they have access to one but not the other, it's no go. So if we had a malicious employee that left and they still had the encrypted file, we could remove their access to the key and they would never be able to get anything from that file. So that's a huge plus when it comes to PCI, just knowing who has access to what and when. So yeah, it integrates with AWS KMS. Only users that have access to both keys can access it. It's just all about the threat prevention, being able to point out this is only accessible via these routes. It also gives us the ability to let our CI/CD pipeline decrypt variables without giving them plain text files, which is another huge thing, because anytime we have to move something from one public space to another public space, kind of gives you the heebie-jeebies when you're in operations. So knowing that we're just moving encrypted files via encrypted methods is very nice.
So Katie, some of the what you were describing about the heavily leveraging Git in here, calls to mind GitOps. I don't know, have you followed up on any of that? WeWorks is doing, basically really completely building an automated process around, a Git workflow for managing the Kubernetes operations, even suggesting like you shouldn't even use kube control, right? Everything should be coming through pull requests and executed through there. Was that something you guys looked into, or it sounds like you're already kind of in a similar place?
Yeah, it's funny. It's one of those things we started doing before we really knew there was a name for it. I was one of the first people to jump on infrastructure as code, check it all in, let's get committed, so we know exactly what our state looks like. So while we've never actually called it, I guess, GitOps on our team, that's exactly what we're doing. Our Git, what's checked into Git is the exact representation of what's in prod right now, and it's just the only thing that deploys it is a pipeline. So once it's checked into Git, there's a PR and it's merged. Someone just clicks that button and it's all going through the pipeline.
Great. I'll point out Helm. Obviously, we're not talking about threat stack specifically here, but I think you've used Helm to manage part of the threat stack deployment too, right?
Oh, that's actually true. Yeah. So we make packages of our entire environment, and since you guys released threat stack as a container, it's just part of our package now. When we deploy, if we ever had to deploy a cluster from scratch, our production environment would come up and it would automatically deploy the threat stack agent, and that's how we do patches to new agents if we need to, and those kinds of things.
Cool. Well, glad we fit that for you too.
Yeah, it definitely made things easier than trying to show in the user data where we were downloading the agent and confirming it was running in the logs. So just being able to be like, no, the pod's running, we know it's working, and here's the data, just makes the audit a lot easier. I believe you guys released that in August or September, and we jumped on that immediately, and we had our audit back in October, November, and it was great to just be able to like, nope, it's running, we're happy.
Okay.
So now we're on to requirement 8, which is identify and authenticate access to system components. I mentioned this earlier, audits are all about who has access to what and when. So the big challenge for us is how we wanted to handle user authentication into the cluster. How do we manage integration with the new system? If our developers get another account, will they know which credentials they need to use for what? What if they accidentally log into the prod environment instead of the dev and staging environment? We don't want them to have something else they have to worry about. We are already using AWS, and they already had IAM accounts, which is identity access management accounts, to log into AWS console for things like S3 and RDS. So it wasn't a new account, but we were repurposing one they already had, and we're already using some kind of single sign-on for AWS as well. So it just was easier to streamline that. So there was a tool called Heptio Authenticator. It has since been rebranded since we adopted it anyway. Some of us are using Heptio, some of us are using the new version, which is AWS IAM Authenticator. It's actually supported and managed by a lot of AWS developers now. So what it does is it just lets you, once you have a credentials file to use like the AWS CLI, it just hops on whatever token or access keys you already have configured, and it just checks to see if your user has permission to a specific IAM group or role. If your user doesn't, then you have no access. If your user does, they try to map that to a service account. So there's a bit of setup to get this working because you have to have the service accounts for Kubernetes and you have to have the IAM roles already defined. But it's great. The big one for us is easy user management. If we delete someone's AWS account, they no longer have access to any Kubernetes clusters. And also our CI/CD pipeline. I hate giving user access keys to CI/CD pipelines. So it's huge for us to just be able to assign a role to a Jenkins server in our environment or to a code pipeline or code build. Just assign an AWS role, and they don't have access keys we have to worry about rotating or removing or adding new permissions to. So not having a user for our CI/CD pipeline is huge for us.
Yeah, that was the first thing that popped to mind. This is part of this problem that I hear most often is particularly with CI and permissions and accounts for parts of the build process. Do you have that within your AWS environment, or is your CI process in a mix of different environments?
Yeah, so our CI/CD process is kind of all over the place, and we're actually looking at different tools now. The main thing right now is we use code pipeline to automatically pull the code from GitHub, which then triggers like a code build to build any images that need to be built, which then does a code deploy to deploy anything that we need to be deployed. And that's what we're using right now, and it's great because all of those give you the ability to use IAM roles. We're actually looking at JX right now, which is still pretty new and feels like we're surfing the crest of the Kubernetes wave with that tool, because there's a lot of features that aren't there, but there are a lot of really cool features that we want with it too. So once again, if you talk to me in 6 months, I may be in JX, so it may be a completely different conversation.
Great. Well, that'll be a good one when we get there. So great. And lots of questions are coming in. Folks, keep them coming. I think we're good. Maybe one more requirement, and then we'll transition to the Q&A. So it's great.
Awesome. So let's see here. There we go. So requirement 10, this is the last requirement, arguably the largest one other than requirement 6, monitoring and logging. So the big thing with audits is you have to prove that you're doing what you say you're doing, and not just that things are running, but that they were running. So track and monitor all network to access resources and cardholder data. So we run Prometheus inside of our cluster. Prometheus is scraping data from all of our nodes and metrics. It is pushing that then to Grafana so we can see different dashboards for how our nodes and pods are doing, see if anything's using more resources than it needs, and how that looks. We use Alert Manager to then report off of any abnormal Prometheus metrics. And Alert Manager will go straight to PagerDuty. And it will wake one of the operations engineers up in the middle of the night to see, well, why is the memory going rogue? Or why is this pod not running? Or what's going on in our cluster? We have no idea. All the normal panicky operations things that you get. We also have ThreatStack running. ThreatStack runs as a pod in our cluster. What it's doing, the main thing we're looking at it for is it is running to see, like, did someone just sudo into our cluster? Is someone running any crazy commands? And we went through and we filtered out ThreatStack so that only severity 1 alerts go to PagerDuty. And then any severity 2 and 3 that may just be normal, just maybe one of our nodes or one of our containers doing something like moving a file or editing a file, things that like the devs may have added for functionality that we're not sure about, those go to Slack and then we can review them. One of the things we do is every Thursday as a team, we go through all the severity 2 and 3 alerts for the week, and we determine if we need to reevaluate how we're ranking them. Should they be severity 1? Should we just silence them? Should we tweak the thresholds, and how we just want to manage that alerting? But we're using it as our intrusion detection, and it's been really useful. It's fun because whenever we make a change in operations, it'll send off it'll set off the page because we don't silence it beforehand. So like our like compliance officer will be like, what's going on? Who is that? And we're like, no, there's a ticket for it. It's fine. It's all approved. But that's how we know the system is working.
Yeah, so I think the challenge in general in monitoring, right, is this information overload, and how do you get the right information out of the noise and the signals. So maybe can you tell a little bit about the sort of onboarding experience you had to Threat Stack, or you can talk about Prometheus as well. How did you kind of fine tune that product to help you sort of get the information that was right for you guys and wasn't too much?
Yeah, definitely. So the first thing we did is we bought the Threat Stack AWS config tool. So what that does is it scans like all of our security groups, our network rules, and it looks for things that don't follow by the AWS best practice, best security standard, the 72-page document that AWS expects everybody to read. And we remediated on that. Well, we're like, well, why do we have access keys we're not using? Well, this security group's not used. Let's just get rid of it. Somebody needs to rotate their password. So we started there, and once we felt comfortable with how that looked, we then turned to the agent, in this case, the container in the pod that we deploy to our cluster. And we started off with just the PCI rules, just the things we thought, well, we need this for compliance. We let that run for a little while, and we were tuning it. We got a bunch of alerts at first, and we're like, well, okay, let's turn this down, or let's tweak this rule because maybe our standards are a little rougher or a little weaker than what PCI suggests. So we just kind of adjusted the thresholds to meet what we wanted. Once we got it to where and we started like sorting them, like this is severity 1 by our standards, and this is severity 2 because we have other controls in place to prevent this. Once we got those in place, we're like, well, let's not just do PCI. Let's see like what are like the ISO standards. Let's deploy that and see how that looks. So then we turned those on, and that was more noise. Then we tweaked it some more. But we're now in a really good state where when we get a severity 1 alert, we know, get up, get to your keyboard. Things are actually on fire, and it feels good to be at that point now.
Yeah, great. And I think that's a good practice that we see, right? Is sort of starting with more things off than on, right, and gradually adding more as your confidence goes up. And I think that combination of signals from a source like CloudTrail plus layering that on with the signals you'd get from your containers or your host-based infrastructure is pretty important.
Definitely, and CloudTrail is always a fun one because like we get the alerts for like auto scaling. Well, a new node has disappeared, but we also get you created a new user, and you always get the people watching the alerts panicking, and you're like, nope, it's approved, it's all good. But it's good to have that monitoring in place to know that if someone did get like root access to our account and started making things, we would know immediately because that alert.
And is that something that the auditors have pointed to specifically, that they've required you to have good answers for how you how you monitor and control that sort of thing? Yeah.
Definitely. They always come at you and they're like, well, if this happens, how would you know? How long would it take you to find out something has happened? How long would it take you to remediate the process? From when you found out to when the fix was in place and everything was resolved, what did that timeline look like? And you have to do incident reports on all of these. And we actually use threat stacks. So when you look at the alarms, you can click dismiss and then give a reason. We use those, especially for severity 1 alerts. We're like, well, this was planned. This was like regular maintenance. We have an approved ticket for this. This was an emergency fix because of X, Y, and Z. It's all part of our process. And then when the auditor does come into the office, and they're like, well, you had an incident on March 3rd. What happened? We're like, well, here in Threat Stack, it shows that someone logged in at this time and we were able to restrict their access here. Or that was actually just one of our users. That was just one of our devs, like doing scheduled maintenance. We were updating our Kubernetes cluster, or we were changing X, Y, and Z. And that's all documented over here in the Git log as well, and it's all related. And being able to having that documentation gives you a huge advantage, because when you're at an audit, hiding information is very bad. If they find it without you having told them about it, especially an incident or something where you're breaking compliance, it's just better to get that in front of them right away, and having all that documentation and just the entire workflow of what that incident looks like really, really saves your neck.
Well, I think that's a good segue. I think you're going to touch a little bit next on, that specifics, right? So how do you actually engage with the auditors once you've set up all of these really good controls?
Yeah, so a lot of your communication with the auditor is probably just going to happen over messages. So there's like 188 requirements. Most of the time, they let you submit your answers via email, or they have some kind of portal where you can be like, well, this is our process for each requirement. But then for the ones that they need more detail on, they'll come and talk to you in person normally. And when that happens, the key thing to remember is talk about your versioning, talk about the technical controls you have in place, your user access controls, talk about any logging and monitoring you have around the requirement they're asking about. If they're like, well, why does it work this way? Don't ever be like, oh, it's a black box, I don't really know. That's the worst thing you could say. You could say, well, maybe someone else knows, but never say, we don't know why it works that way, because that's a huge red flag, and they'll start asking more questions and digging in even deeper. It's very important to understand how Kubernetes works. It is a really complicated service. There are a lot of settings, but in order to make it compliant, you really do have to know what every knob does, and everything you've turned on, you have to know why it works. So that when the auditor comes and is like, well, how do you scrape metrics from cAdvisor? How is that exposed? Is it exposed from the outside? You really need to have the answers to those questions. The big things being, if you choose Weave or Calico or Flannel, you should know how that works and how the communication between your services work. So just always fall back on technical controls. Feel free to have reference documents. Like, I was Googling things when they were asking me questions, because I was like, oh yeah, I know there's a control for that and I know the answer. And I was like, just let me reference my notes. Don't be afraid of that. Like, they don't expect you to remember everything. It is a complicated system. They're not going to know everything about Kubernetes. They may not have ever encountered an environment doing PCI compliance with Kubernetes. It's still a pretty emerging technology. But just always fall back to technical details. Don't try to hide anything. Just always fall back to those technical controls and how you remediate things. Timelines are huge. So when we found out about this flaw, it took us this long to find out how it was happening, and this long for us to get a plan in place, and then this long to get to the end of that plan. And like, they expect people to fail. It happens. Like, there's no way to always be compliant all the time unless you're insane and you're throwing lots and lots of money. So they expect there to be an incident or two in your year. Just don't hide them. Hiding them will get you an instant fail. Owning up to it, being like, well, there was like a slight breach of process, but now we've updated the process to be more clear. And that's really how you survive the audit.
Great.
Yeah, and so if you're moving to Kubernetes or moving just to be compliant, I highly recommend just reaching out to the community. That's the only way I was probably able to survive the migration to Kubernetes. I was constantly going to meetups. I was in Slack groups. I was in forums. I was opening up issues on third-party plugins on GitHub. Also, don't feel like you have to build all the integrations that you need. There are tons of custom authentication controllers for pretty much every cloud platform, for LDAP, for all of that. There are custom resource controllers for if you want to do like Prometheus or Grafana. All those things already exist. You have your monitoring and logging stuff has already been solved for you. A lot of the major monitoring platforms already have Kubernetes Helm charts available in the stable charts repo for Helm. Just look to see what's available. Ask other people what they're doing. Just don't be afraid to reach out to the community. We're constantly evolving. The documentation tends to be a few steps behind because it's evolving so fast. So the best source of information is the people.
Well, and yourself doing things like this is a great example of that. We're incredibly thankful for you sharing your expertise. Heaps of questions pouring in here. I will kind of quickly, Katie, if you want to skip to the next slide, then I'll just say a word or two briefly about ThreatStack. I think we had an opportunity to talk about that. You already basically explained the role that we're playing there. In brief, so many of the things that you talked about today are about being able to see and document things in your system, right? That's this notion of observability, and that's why we exist as ThreatStack, to fit into solving these problems for you, right? To give you that visibility from the signals that are coming from all of these different parts of your environment, from the infrastructure control plane, as you were talking about, managing users, all the way up to the application tier, and kind of giving you the insight, the visibility, and the context for that, so that you can you can reduce the risk of breaches or secure your containerized environments, or in these cases, be able to meet those regulatory needs and be able to answer those questions for your auditors. So we've been thrilled to be able to help you with this journey. We'd love to be able to do the same for other folks who might be grappling with some of the implications of PCI in a containerized world. So feel free to swing by our threatstack.com to check us out. Meanwhile, why don't I switch over to some of these questions? I think we've got about 15 minutes left, which is terrific. We'll also keep some of the questions that we don't get to, and we'll follow up offline with folks if we're able to. So bunch of questions here about specific technologies that you're using, but I'm going to start off with one that was a little bit more about the organization and your approach to it. The question was, you're a small team, you're only 3 DevOps folks. The question was sort of what level of seniority were the folks? How long did it take you to get to PCI level 1? Are you looking to grow that team? So I think that would be something to be interesting to start off with, a little bit about the team, the culture, the time required to get here, and what you're looking for as the next stage in the development of what you've done so far.
Yeah, definitely. So I'm going to kind of tackle this from 2 points, Kubernetes, and then tying in the compliance part afterwards. So our migration to Kubernetes and securing it, it was just 2 of us. Neither of us had done Kubernetes before. It took us 8 months to migrate completely all of our services into Kubernetes, and then another few months to actually lock it down to a point where we could say, yes, this is PCI compliant. The entire time we were communicating with our third-party auditor, asking them about, is this control valid? Is that control valid? And we had a point person whose her sole job, she's like an angel, she's amazing, was just doing the documentation and talking to the auditor for us. She was our compliance officer. She was kind of the filter so that we could focus on the actual hands-on keyboard. Let's lock this down. Well, what services are actually compliant? What services can we use? It was just 2 of us. I would say we were both senior DevOps engineers, but neither of us had done Kubernetes. We had some microservice experience before this, but it was a huge learning experience for both of us, and it did take us 8 months to get everything up and running.
And are you growing that team? Are you expanding?
Yeah, so we actually just grew up to 3 people very recently, and we're probably going to look to adding 1 or 2 more people as our company grows in the next year. But no, with 3 people, we're very comfortable running all 3 clusters right now.
That's great. Okay, so let's jump into a couple more about sort of your environment and your stack. It looks like lots of folks are interested in the nuts and bolts here. One that I think is always important to PCI and compliance and regulatory issues in general is logging. So there were a couple of questions about what are you doing for log collection and aggregation? What's your log stack look like?
Yeah, so our log stack's kind of fun because we get a lot of logs. We get a lot of responses from so we get like XML logs back from the booking providers, and our number 1 goal of logging is to filter that out. We run FluentBit as like an underlying service on each of our nodes that collects all the logs and then ships those to an aggregator we also have running in our cluster. That aggregator will then do some like smart sorting. It'll send all logs to a Kibana cluster. We use Elasticsearch in AWS. It'll send every log we have there, which will then after 2 weeks be archived to S3. And then from there, we will send all the important application logs that we need for debugging and for our devs to easily parse. We send that to Papertrail. None of our logs sent to Papertrail have any PCI information in them, but nevertheless in Papertrail we do use some of the user management so that only certain users can actually edit the logs, and even fewer users, some users can read the logs and even fewer users can edit or delete logs. from Papertrail. And then after 2 weeks, we also archive all of those logs to S3. And if we ever needed to, we could reload those logs to either Papertrail or Kibana. That's kind of what our logging stack looks like right now.
And did the PCI requirements dictate the design of some of that structure?
They dictate how long we keep everything. We have to keep logs for our PCI environment for at least a year. At this point, we're not getting so many logs that we feel the need to purge anything from our archive. So right now we're just kind of keeping things indefinitely until that S3 cost does start seeming kind of like a hill to climb. But no, the big thing with PCI is don't put anything in your logs like credit card information or CVVs that your general users or your general devs can see. And you just have to keep logs for your for all your PCI applications and databases, and you have to have audit logs, and all of that needs to be somewhere for a persistent period of time.
Great. We did have a couple of questions on container registries. So what do you use? And again, when it comes to versioning containers and container registries and making sure that, safe, secure images are used, was there any PCI compliance factor there?
So right now, we just migrated all of our containers into AWS ECR, and the only people that can access or see those containers are our pipeline and pretty much our DevOps team at this point, our general admins in AWS. We have it restricted for who can upload and edit those images, so it's literally just the pipeline and us. If there's an emergency and we have to do an emergency deploy, we can still do that, but it's restricted so that none of our devs or general team can do that. ECR is under the umbrella of Amazon's PCI compliance, so it is compliant. It's all about the security restrictions you have around that and the lifecycle policies on your images. Big caveat with ECR is that out of the box, you only get 1,000 images per repo. So you either need to lift that limit or you need to just watch that so that if you do have to do an emergency deploy and build a new image, you're not hitting that cap during an emergency. Also, another caveat, ECR did go down right after we finished migrating for a few hours. So there was a panic where we were trying to pull new images and ECR was just unavailable. So we're now starting to think about, well, maybe we should do some cross-region image management, just keep copies everywhere. But I think we're still a little far away from that right now.
Great. Had a question about intrusion detection. I think I know the answer, but maybe you can talk to that a little bit, and some of those other types of monitoring things that are important.
Yeah, so we use ThreatStack for intrusion detection. We have it running on all of our instances in our PCI cluster. We also have like a Qualys scanner for vulnerability and pen testing that we do once a quarter. We're literally paying to host an EC2 instance to run once every 3 months. So those are the major security controls. We mainly utilize a lot of like AWS things. So we use like their WAF, we use network ACLs. I'm assuming those are the kinds of security controls that question was aiming for.
Yep, great. A few questions about sort of rolling your own versus using out-of-the-box kinds of things. One person was asking about, your own kind of Prometheus-based monitoring instead of a commercial service like Datadog. Have you had a specific kind of philosophy about build versus buy? To maybe talk a little bit about some of those choices.
So the big thing for us was we started off with no monitoring, and then we've just kind of been building it out. Prometheus just seemed logical because we are still at a point where we are very cost conscious. We had New Relic for a while, but it just didn't seem, it was like bang for your buck kind of thing. How many people are actually looking at this? It doesn't have to be pretty if it's just the 3 operations engineers looking at it. None of the devs seem to care. So maybe we can scale down on how much we're spending on monitoring. So we did build a lot of the Prometheus exporters that we were using. And then there were a lot of out-of-the-box exporters for like Redis and Postgres. But we have actually recently just switched to using, we scaled down like some of the more basic Kubernetes monitoring we were doing in-house, and we've started using like SignalFX. They have infrastructure monitoring that we're really enjoying for the price point that we were looking for. But there's still things that like Prometheus gives us the flexibility to do some like, well, how fast are our flight queries and how fast is this and that? And it's just easier for us to build those out than to try to find a platform that fits specifically what we're looking for. So we kind of do a combination of both right now.
Great. I think this is probably less related to PCI specifically, but there have been a bunch of questions about EKS. So was that something that you considered when kind of picking, managing your own Kubernetes environment versus using sort of more of a managed service?
Yeah, so when we were migrating to Kubernetes, EKS was still in preview, and we tried so hard to get into that preview, but the timeline just wasn't there, so we ended up just doing it on our own. Once EKS became general, we realized we picked a lot of the same services that Amazon's using for EKS, so like we were using HepDuo Authenticator, and then as soon as they released EKS, HepDuo Authenticator was rebranded AWS IAM Authenticator because that's what they're using for EKS. My only issue is that we've built out Kubernetes and we're really enjoying the management of like the kube system and a lot of like the kube DNS and those other things. And you just don't get that insight when you do EKS or a managed Kubernetes service. I think it's something that as we scale, we'll probably reevaluate and maybe we'll move to a managed Kubernetes. But right now, we're really enjoying having keys to the kingdom because there's a lot of in-depth analysis about how our applications are working that we get by being able to see all the underlying system calls.
You suffered the pain of figuring it out for yourself, and now you get to reap the benefits.
Exactly. I don't want to give it up yet.
Great. Well, hey, Katie, there's so many good questions still, I think, but unfortunately we're running out of time. So I think what we'll do is we'll capture those questions offline and get back to some individuals and look for some other ways to reach out. But obviously this is a really important topic that lots of folks are dealing with. Lots of things still around secret management and user access controls and ingress and, just so many topics that I'd love to, maybe get back together again with you at another point in the future. We can go into some more detail on some of these, but really, I can't thank you enough for taking the time today.
Awesome. Yeah, no, this was a ton of fun, and I hope to see some of you guys at KubeCon in the future or at any of the Boston meetups. And I hope you guys all learned something today.
Absolutely.
And Alan, thanks so much. Thanks, Alan.
Tim, I'm here. Tim, hey, man, thank you. Right. First of all, you made my job really easy, but also thank you and ThreatStack for putting this on and sponsoring it. For those who may not be all too familiar with ThreatStack, go check out threatstack.com. It'll do you good. I spoke to I've been speaking to so many people since KubeCon, and this whole area here, it's such an emerging practice that best practices are really kind of still solidifying, if you will. And so there's so much going on. You got to stay on top of it. A company like ThreatStack can really help you with that. Tim, great job, man. Great job to the team. Katie, thank you. Continued success with Lola. The next KubeCon, by the way, is in May in Barcelona. Not a bad time to go to Barcelona. I think there's another one in June in Shanghai, and then they'll be coming back to the US. So absolutely. If you are there, MediaOps is there broadcasting, so check it out. Until then, everyone, though, this is Alan Schimmel. Great webinar. Hope to see you soon on another DevOps.com Container Journal webinar. But until then, have a great day, everyone. Thanks again. Bye-bye.